we'd like to present a work entitled Machine-Mediated Teaming, Mixture of Human and Machine in Physical Gaming Experience. In this study, we present a concept to reconstruct team sports with interactive technologies. We conducted user studies with our developed system based on Tug of War. We report findings obtained in user studies. Sports have evolved and diversified under the influence of technology. For example, the invention of the gasoline engine led to the birth of motorsports, and computing technologies formed esports. Technologies in recent years have also opened up new gaming and sports experience. However, in games that require highly dynamic movements, it's difficult for people with different fitness levels to physically interact and team play on the same field. In this study, we focus on team sports and explore how interactive technologies can reconstruct team sports. We propose a formal mixed human-machine sport named Machine-Mediated Teaming. We call this MMT. In MMT, some players participate in the game by borrowing the motor skills of physical machines. In MMT, there are two types of players. One is a player that we call the bodily player, BP, and the other is called a machine-mediated player, MP. BP uses their own body to perform physical movements in the game. On the other hand, MP participates in the game by controlling specialized machines from outside and performing movements. BPs and machines coexist on the field and physically interact with each other. A key factor in creating a team sports experience in MMT would be how to offer equal influence to BPs and MPs in the game. This is because if the influence of the BP and the MP on the game is not balanced, there will be no room for cooperation and the development of team relationships. However, it's not obvious how equal dominance can be achieved for two completely different entities, human and machine. To address this issue, the study aims to reveal insights into understanding and designing MMT experiences. As a case study, we developed a specific system for an example of MMT. We focused on Tug of War and designed the system by placing some team members as MPs. This is because that Tug of War as a base sport for its simplicity and strategic aspects, and it requires highly dynamic actions. In our system, the BP uses its own body to pull the rope, while the MP participates in the game with the machine behind the BP. The MP can pull the rope externally with human scale force by leveraging the machine and the control interface. Our system consists of a machine to present human scale pulling force, a handle device to measure the BP's action, and a tablet interface to control the machine output. For the machine's actuator, we adopted a large diameter brushless DC motor with a low reduction ratio to increase its back drivability and get high torque output. The handle has two pairs of load cells. We can estimate the BP's actions based on the tension of the rope. The acquired tension data is streamed in real time to the main control computer. The MP controls the machine output by manipulating a slider displayed on the tablet. To understand an MMT experience, we conducted a set of user studies where participants played Tug of War games using our proposed system. We initially conducted a pilot study to find out the appropriate settings for preparing the MMT experience. After the pilot study, we analyzed how the revised settings contributed to the games in the Exploratory study and discussed the implications for designing future MMT games. For user studies, we designed several regulations of the game. We set the duration of a game to 1 minute. If the winner was not decided within 1 minute, the team which had pulled the rope farthest to its own side won the game. We conducted 5 games with 4 participants in each user study. We also introduced a parameter called machine energy to add a strategic element to the game. Machine energy indicates the total amount of force that the machine can provide during a game. In the pilot study, we set the machine energy to 3,700 joule. This value means the machine was able to run for 20 seconds at maximum power. As a result of the pilot study, we found issues that needed to be resolved in the machine energy and the goal position. First, we found abundant machine energy can have a negative effect on strategic coordination within a team. Second, we found that the distance to the goal position was too short for the players to act strategically. In the exploratory study, to encourage strategic cooperation within a team, we changed the 2 parameters, the machine energy and the distance to the goal position. Based on the pilot study, we changed the machine energy to 1,850 joule. This value is half that of the pilot study. Also, we enlarged the distance to the goal position. The distance was increased by 0.5 meter from the pilot study. According to this change, the field size was also enlarged. As a result of the exploratory study, we successfully observed an increase in participants' strategic cooperation compared to the pilot study. We highlighted 2 games that were particularly spectacular and analyzed in more detail. For more detailed description, please see the paper and supplementary video. Based on the data obtained from the user studies, we clarified 3 perspectives: machine stamina, action space, and explicit feedback. We argue that they should be considered when designing future machine-mediated teaming systems. Please see the paper for more detailed discussion. Finally, this is a summary of this study. We proposed machine-mediated teaming concept and investigated the user experience of our concept with a case study. We developed the system based on Tug of War, a one-dimensional physical team sport. And we conducted user studies to validate our concept and reveal several insights for designing MMT and further research. I'd like to conclude my talk. Thank you for listening.